All right, so next one, 1823. We are given a circuit with both resistors and capacitors. Oh no, sorry, with resistors and batteries. And we're asked to find the current in each resistor. We're asked to find the potential difference in the 200 ohm resistor here on the left. And then we're asked to find the power delivered by each battery. So I've highlighted this one in the middle because we're given that this is 360 volts. So what that means is this is going to have the strongest current coming out of it as opposed to the 80 volt or 40 volt battery. So the first thing we need to do is we need to label the directions of the current. So since this is positive and this is the largest, I'm going to say that we're going to identify the current as coming out of this way first. And using Kirchoff's rules, we can then use that all of the current going into a junction is equal to all of the current going out. That'll give us one equation that we can use to solve. So this current will equal the sum of these two currents. And we'll continue from there. So we also need to name the junctions, right? Which is something I already did. We have A, B, C, D, E, F, G, H. That'll help us. So let's draw our current. So we have a current going this way. We'll call this current. Well, we're going to have, let's see, 1, 2, 3, 4. We'll call this one 3 because we're just going to go in order. It's going to be 1, 2, 3, 4. I'll show you what I mean. We'll call this one 3, right? And this is going to be going this direction. And this one can be 4, since this is the last one. Again, I'm going to have 1, 2, 3, 4 different currents coming through here. So we'll call this one, this is going to be a temporary current. And I'll show you what I mean. Because we have this one coming out, this one going to the left, this is actually going to be the sum of these two, because this one is going to go into this junction and be equal to this one and this one coming out, right? So that's going to be 2, and that will be 1. So again, we just started from the strongest battery and then drove our current from there. So 3 is equal to T plus 4, which is going to be, I'll label it like this. Current 3 is equal to my temporary current plus current 4, where the temporary current that I had just drawn is going, because I labeled it this way because it's also going to be equal to these two currents. It's going into this junction and equal to these. So what that gives us is I1 plus I2 plus I4. So I3 is equal to these three things. So that will be one equation that we can use to solve for the currents that we're asked to find in each resistor. So essentially what we're looking for is what are the values of each of these currents. Okay? So that's a good starting point. Next we can move on and we can use Kirchoff's second rule, where the sum of all potential differences is going to be equal to 0 in any loop. So in this loop, they should all sum to 0. In this loop, they should all sum to 0. In this loop, they should all sum to 0. And if you wanted to use the outside loop, also they should sum to 0. So since we have 4 currents, we're going to need 4 equations. This is one. And we have 1, 2, 3, 4 loops that we could use to come up with 3 other equations. We need 3 more equations. So let's just start with the loop on the left. 1, A, B, G, H. This one here. Loop A, B, G, H. And now what we're going to do is we're going to pick a direction. And we're going to traverse this loop in that direction. And using the rules that you can find in the book, in my version, it's on page 600. There's just a little figure 1814. But the section is 18.4. It describes all of this, right? So anyway, as we're traversing the loop, we're going to find that we want to sum all of the potential differences. So here, we're going this direction with the current. So this resistor is going to be negative. This is going to be a negative I1 times 200 ohms. Okay, and we keep going around the loop. We're going from positive to negative. That's going to give us a negative EMF. We'll call that E1. And then we continue down. Right, and then we're going, and then we're going, I don't know what I did. We're going this way against the current through the resistor, so that's actually going to be a positive value. So positive I2, because we are now on the section of wire with current 2, times 80 ohms. And that's all equal to 0. Okay, so E1, or this EMF1, this is actually equal to 40 volts, right? So what we want to do is we want to solve for one of these. I'm going to say let's solve for I2. Let's just make things a little easier on ourselves. So we're going to have I1 times 200 ohms plus 40 volts, right? And then we take 80. So we can pull out a common factor of 40 here. That's going to leave us with I1 times 5 plus 1 over 2. So I2 is equal to that. So I'm going to rewrite it. Yeah. Okay, good. So that's a great start. So that's equation 2. So now we have equation 2. Let's write this in red so we can keep track. That's equation 2. That's equation 1. Okay. So now moving on, let's do another loop. We need another equation. We have 2, we need 4. So let's do B, C, F, G. And then we will go around similarly to how we did before. So starting here, we'll go with the current through the resistor. That's going to be negative. From negative to positive through this battery is going to be positive. This negative to positive through this battery is going to be positive. With the current through the resistor is negative. So again, we have negative, positive, positive, negative values. So let's write these down. So we have, what was it, loop B, C, F, G. The sum of the potential differences should be equal to 0. It's going to equal, we had 80 ohms. That's negative 80 ohms times I2 plus 40 volts plus 360 volts minus I3 times 20 ohms. And that's all equal to 0. So just following the same pattern that we did before, we solve for one of these variables. We put I2 in terms of I1 here, I2 in terms of I1. So we can solve I3 in terms of I2, which we can later put in terms of I1 as well. So then we're going to say that I3 is equal to, what do we have? We have 400 volts. So we'll take this to the other side. We have 400 volts minus 80 times I2. This is all going to be over negative 1 over 20. Wait a minute. Oops, that doesn't go there. I already did that. Okay, so then that leaves us with, so we can factor out 20, right? We can factor out 20. That leaves us with 20 volts minus 4I2. And that can be further factored if we want. I'm not sure if this is going to help us, but let's just write it out this way. Okay, so I3 is equal to that. That's our third equation, equation 3. And then we need one more. And so it's probably going to be a little, like, one step easier if we go around the outside of the loop, because we have 1, 2, 3 elements on the outside of the loop. Versus if we do this loop, we have 1, 2, 3, 4 elements. Either way is fine, but let's do the outside one. Yeah. Okay. So what is that going to give us? So current 4 is going this way. It's going, and if we go, let's pick a direction, right? So what I've been doing is I've been going this way. I'm going to just stick with that. So now we're going positive to negative. That's a negative EMF. We're going against the current through the resistor. That's a positive potential difference. And here we're going, current 1 is going this way through this resistor, and we're going with the current. That's negative. So, okay, so that means we have negative, positive, negative. All right, writing this down for loop ADEH. So we have, what is it? It's ADEH. Sum of the potential differences around this loop should be 0. So 0 is equal to, so we had, what did we say? It was negative 80 volts plus I4 times 70 ohms minus I1 times 200 ohms. And let's just double check that. So we decided to go this way around the loop. This is going to be negative because we're going positive, negative. This is going to be positive. This is going to be negative. Good. Okay, so now, doing the same thing that we did before, let's just put I4 in terms of I1. I guess I1 is our chosen variable here that we're going to find first. Right? So then we have 200 I1 plus 80 volts. And we put all of that over 70 ohms, right? And then we solve for this. We could take pretty much a factor of 40. And that leaves us with 5I1 plus 2. Kind of drop my units here, but all of this is going to come out in the units of amps. Volt over ohm is going to be an amp, and this is a current, so that's also amps. Okay, so this is 4, 7, 2 plus 5I1, and this is our fourth equation. So now we have 4 equations and 4 unknowns. Remember, we're trying to solve for 1, 2, 3, 4 different currents. So let's write these out. I3 is equal to I1 plus I2 plus I4. I4 is equal to 4 over 7. 2 plus 5 I1. I3 was equal to 4 times 5 minus I2. I2 was equal to what was it, 1 plus 5I1 over 1/2. Okay, now we use these and we solve for the currents. So notice that I3 is in terms of I2, but I2 is in terms of I1. So let's plug in I2 into I3. So we have I3 is equal to 20 minus 5. I2 is equal to 20 minus 5 halves times 1 plus 5I1. That's going to equal 20 minus 5 halves plus 25 over 2I1. Nope, I made a small mistake here. It's not 5, it's 4. Because it's 4 times 5 and then minus 4I2. So this is actually 4 over 2. And then we actually end up with just double checking my work. I know I made a small error here. This is what you should end up with, 18 minus 10I1. Okay, good. So this is what I3 is equal to, and then we can take this and we can actually plug it into the first equation here. So let's do that. 18 minus 10I1 is equal to I1 plus I2 plus I4, right? And remember that we have I4 here is in terms of I1. I2 is in terms of I1. So all we have to do is replace these, replace I2 and I4, and we solve for I1. So 10 minus I1, remember this was I3 here, is equal to I1 plus I2 was 5 halves I1 plus 1/2 plus I4, it was 8/7 plus 5/7, no, plus 20/7, excuse me, 20/7 I1. Remember, because we had these factors of 4/7 out in front, right? Okay, so then we just sum up all the like terms and we solve for I1. So I1, 1 plus 5 halves plus 20 over 7 plus 10. Then we have plus 1/2 plus 8/7 minus 18, and this is all equal to 0. I just took these terms to the other side. Took these to the other side. Okay. And so then if you just plug this into a calculator, I mean, you could do it, we could do this by hand, but why take the time to do that when you could just put it in Wolfram or something? So then we end up with, I did both ways, by the way, and you end up with the same answer on both sides. So what you would do is take this to the other side. Yeah, and then so you end up with is equal to 1 amp. Okay, so then you plug this into, say, I4, and then you plug it into I2 to get those values. So I4 is equal to 4 over 7, 2 plus 5 times I1, which is 1. So that's equal to 4 over 7, 2 plus 5. That's equal to 4 over 7 times 7 is equal to 4. So I4 is equal to 4 amps. Then I2 was equal to 5 times I1 plus 1 all times 1/2. I1 is 1, so that's equal to 6 over 2 is equal to 3 amps. I3. We plug in I2 for this one, right? 5 minus I2 is equal to 4. 5 minus 3 is equal to 8 amps. Now, is that what I got before when I did this? Yep. Okay, so writing all this down. So here are the values that we were looking for. Is equal to 1 amp is equal to 3 amps is equal to 8 amps is equal to 4 amps. Okay, so that's part A. That's why I made this its own video. Some of these just take so long. So this is delta V is equal to IR. We're asked to find the potential difference across the 200 ohm resistor. And so for our setup, for what we defined, we have current 1 running through the 200 ohm resistor. So we use delta V is equal to I times R for this. Current 1 was 1 amp times 200 ohms. That gives us a value of 200 volts in that resistor. C, we're asked to find the power. Power is I squared times R. It's also equal to V times I. Right? And so using that, for each battery, we had the one was 40 volts, and that was current 1, right? So let's just figure this out real quick. We had so actually we had, for the 40 volt battery, we had current 2 running on that section. For the 360, we had current 3, and for the 80 volt, we had current 4, right? So then current 2 was 3 amps. So that's equal to 120 watts for the 40 volt battery. For the 360, we had current 2, which was, no, sorry, current 3, which was 80. $360 volts times 8 amps is what I'm trying to say here. $28 kilowatts seems pretty high. And then we had, what was the last one? I had to scroll really far. It was 80. Oh, that was the 80 volt, and then current 4. Okay. So for the last one, then we just plug in the same formula, which was 80 volts times 4 amps. I'm just going to give you 320 watts. So that's what I got. So you have a really high current running through a powerful battery, right? So that's going to give you a pretty high energy output. So double check these. I just use this formula to do it. Okay, next problem. Oh wait, before I end, it's actually 2.8. There we go. That makes way more sense. All right.